So welcome to another edition of GoPro Earthing. This is Justin coming to you. So I just wanted to show you guys something that you've been asking a little bit about. This is Arduino. This is like an Arduino Uno clone board. This is Arduino represented in its most simplistic form. Get this nice and close so you can see the pins. You can see they're labeled. So if you want to take a really close look, you can go ahead and pause it. So some of you had asked to tell you a little bit about Arduino, because some of you have seen it applied in the car application form factor, but don't really know much about it. So these are just some really basics. Of course, there's lots of videos on YouTube that are really in depth. You can do a deep dive on Arduino and find out everything you ever want to know about it. This is not that video. This is just something really simple just to get you thinking towards car applications and to get you to really get your feet wet on Arduino. So, just full disclosure, I am a programmer. I've been programming for years. However, when it comes to Arduino, it's something that I picked up just when I wanted to learn how to do my active arrow. So it's nothing that I had previous experience with. I had no experience with the language structure whatsoever. It's something I just picked up a cheap kit and just started programming on and quickly started to build out some projects with it. Active Arrow is one of my projects that's powered on the MR2 right now. And the other project that is currently running is my mode selection for launch control, boost control, etc. on the MR2. So that's all powered by this simple Arduino. This Arduino right here costs $10 on Amazon, and it's available on Prime. So just quick overview. How do you power this Arduino? So you have two options here. You can power it by USB 5 volt. So that's right here. You can just plug this into your laptop and that will power this board up. That'll allow you to write code directly to the Arduino. Once the code is written to the Arduino, it will execute in an endless loop, and you don't have to keep uploading the code. The code is written to the EEPROM here. So that takes care of all the execution. The great thing about Arduino versus, for instance, a Raspberry Pi is that Arduino has a low overhead. What that means for the people that are not used to computer jargon and technical things, I'll break this down to layman's terms. So basically, it doesn't have to run an operating system, like, say, for instance, running a Windows or something. So think of your computer that you're probably watching this video on. Or maybe it's your iPhone or your Android. When you want to watch a YouTube video, or you want to write something up in Notepad, first you have to make sure that your phone's on. So you have to boot up your device. It takes a while, or boot up your PC, so Windows is starting up. Then you have to log into Windows. Then you have to go to your start menu and launch Notepad or whatever it may be that you want to execute. You don't have to do that with Arduino. Arduino is much simpler than that. All it does is run your code. So as soon as this boots up, it immediately starts to execute your code. So the startup is very negligible. It's almost instantaneous, which is great for when you want to run an application that's going to be powered in your car. So how can we power this in a car? Because I said USB 5 volt. Well, that's what this is for. You can run a standard DC socket into this, and this can be powered up by 12 volts. So you can write your code and send all your code over via your laptop or your PC or your MacBook, as in my case. And then when you're ready to go, you can unplug this and plug it directly in via 12 volt on your car. This will immediately start up and start to execute your code. So what does that really mean? Well, in simple terms, it can be as simple as, if you look here and you see these pins here, you can program these pins to send voltage out or ground out. Very simple. You can trigger these pins under certain circumstances to trigger a 12-volt relay. So you can use it to turn systems off or on. So in the case of my mode selection on the MR2, I get these pins to send out voltage to trigger a relay, to bridge a ground or send a power 12-volt signal to turn on my boost controller or turn my boost controller off. And I can trigger all that through a joystick that's built into the center console of the MR2, which makes it a very slick application. And down the road, if I want to add on more efficiency or more functionality to this, I can simply write more code and just use more of these pins. It's very expandable to fit your project and whatever your project needs may be. On this side here, if I get a little bit closer, you can see there's a 3.3 volts, there's a 5 volts, and then there's a couple of grounds. So the cool thing about that is you can, if you power this by 12 volts, when you send out a digital signal of high, that'll go ahead and send 12 volts out through this. But generally speaking, you don't want to power devices directly from Arduino. You want to run this into a relay. And that 12-volt relay will have its own power. And so you can use this as trigger pins to turn on that relay or turn the relay off. So if you think of that, then really the options are endless in terms of your application. You could use this, for instance, for an intelligent power window control, for one touch up and down. You could use this for active arrow control, as I already have on the MR2. You could use this for a fire suppression system. You could use this for a variety of different things. So let me show you what I'm going to use to expand my current MR2 mode selection. So sometimes I like not running a blow-off valve on my car. Some MR2 guys like doing that. I know. You guys want to flame in the comment section. You're going to blow your turbo up. You're going to blow your turbo up. Maybe. But it'll be fun in the meantime. It's not that I just have money to burn. It's just that the research is not conclusive. Will it wear out the bearings in my turbo faster? Yes. But sometimes you just like that. Everybody likes that textbook turbo sound. So I don't want to have to choose between having a blow-off valve or not having a blow-off valve. So I thought to myself, since I've run both in the past, and I currently have a blow-off valve, which is a Greddy Type S clone, I thought, how could I go about making it so I can build into the mode selection on the MR2, controlling the blow-off valve functionality? Because after all, it's something that's mechanical. It's not something that's digital. So I thought about this for a couple months, and this is what I came up with. This is a digital solenoid. Okay? Works very simple. As you see, it's 12 volt rated. So it's normally closed. It has a 1/4 inch NPT on this side, 1/4 inch NPT on this side. So what you do is when 12 volts is supplied to this, it goes from being normally closed to open, and air can quickly come in from this side, from the engine, and out of this side into the blow-off valve, and your blow-off valve functions as normal. But when 12 volts is not applied to this, or ground is turned off from this, then this becomes normally closed. And air will come from the engine and hit here, and it'll basically be capped. That won't send a vacuum source to the blow-off valve, and it won't send a pressure source to the blow-off valve. And your blow-off valve will stop working. It'll still hold pressure, but you're not going to get that venting whoosh noise or whistle noise. You'll just get the So now I reprogram this in the code to control this, depending on where I move my joystick and which mode I put the car in, to give me the instant gratification of having a blow-off valve to not having a blow-off valve. The best of both worlds. So let's take a look at some of the code. So here's my MacBook. You don't need anything state-of-the-art. This is a mid-2012. Here's my Arduino. So let me show you how easy it is to power this up. So just turn on your MacBook, take your Arduino, and take the supplied cable. Again, this is a USB-A cable. Plugs right in. You can take the Arduino, just plug it in. And it is powered on and already running. What's it running? Well, it depends on which code you flash to here. It could be something very simple, or it could be something very complicated. But that's how easy it is to get Arduino running. That's simple. So let's take a look at some of the code that I have. So here you can see this is the Arduino sketchbook here. This is where we write our code. It's very simple. This button right here is to verify our code to make sure that we don't have any errors. This right here is to upload our code via the USB-A cable to the Arduino. The important thing, though, to make sure that you do before you try to upload your code is make sure that the port is selected. So how you do that is you click Tools here, then you go to Port, and make sure that you go to the port that has your Arduino Uno right here. We'll verify that that's selected now, and it is. As you see here, there's a check mark here. So once that's there, you can go ahead, press this here, which will upload your compiled code to your Arduino. At that point, once your Arduino boots up, it's going to go ahead and run a loop. Here's how it works. As you can see, this is just an empty template for what you would write your program in. Up here is where you would declare your variables. Here, this is where you would put your code that runs only once when the Arduino first starts. Excuse me, sorry, getting over a flu. Here you would put your code that's going to run only one time as your Arduino initially boots up. Here in this section, this is where you put your code that is going to loop over and over again. So if you did something like simply put code here, again, this is not computer code. This is just simple so a layman can understand. If you put your code here and then you said, then run this code, again, this is not actual computer code. What would happen is it would start up, it would look and see if you have any variables declared here, then it would run setup one time, as says right here, to run once, and then it would loop through. So it would execute the first code, then the second code, and then it would hit here and come back to the start, and then run your first code, then your second code, and it will continue to do this loop endlessly. It will never stop until your Arduino loses power. Pretty simple. Hopefully you're able to follow this far. I'm trying to make this as simple as possible. Now, let's look into my complex code. This is going to be my code that I have currently set up to run the boost control, the launch control, as well as the blow-off valve or no blow-off valve. Boom. As you can see here, this is a lot different. Again, we have variables. We also have some includes here. But this has still the same layout. So as we go down, you can see some variables are declared here. I have some comments that say what all these variables do. Some more variables here. And look, here's setup. This is setup that I brought up before. This still has the same structure, even though this is much more complex than the default code. But here's setup. This is only going to run once. Again, this is all only running once. All of this runs one time. This section here, I have commented out. That means this will not execute. It will ignore this. When it gets to the end of the code that it's only running once, then it's going to go ahead and start the loop. The loop is going to contain the meat and potatoes of your code. It's going to contain your executions, your functions. It's going to have all the functionality of how your code is going to execute. So again, I'm trying to keep this as simple as possible. Going back up here to the top, I'll explain some of the components. This is not going to, again, be very in-depth, but this is just enough for you to get your feet wet and have a general understanding of how this works. Really, the best way to play with this is to just go out there and experiment with it. Again, Arduino is only $10. Do not worry about blowing it up. You will not blow it up. So if you're coming into this and you have no coding background, this is a great product to get into for just $10 on Amazon and start programming the same day. The software is included, no charge, and you can just avail yourself of some of the code base that's available on the internet and expand your horizons and learn something new. You might decide that you want to do this professionally. So here are the different modes that I have. When you have these two slashes here, this area is commented out. So this whole area right here will not execute. It's just so I can look at this, and it's a reminder of how the car is going to run and the general purpose of the code base. Again, sorry, I'm still sick. So the car has 5 different modes, as evidenced here by this code that's highlighted. Codes 0 through 4, so that's what makes it 5. So 0 is valet, and as it shows here, valet is launch control off, boost control off, blow-off valve off. 1 is power, which is launch control off, boost control on, blow-off valve off. 2 is sport, launch control off, boost control on, blow-off valve on. 3 is Corsa, launch control on, boost control on, blow-off valve off. 4 is killer, which is launch control on, boost control on, blow-off valve on. So everything's going to be turned on. As we look down here, I'm using 3 different relay triggers. One is on pin 2. Relay 2 is on pin 3. And relay 3 is on pin 4. What this means is when I send a signal of high to relay 1, then pin 2 is going to go positive 12 volts. When I send a signal of low to relay 1, then pin 2 is going to be at 0 volts. And likewise for relay 2. A signal of high on relay 2 is going to send positive 12 volts to pin 3 on the Arduino. A signal of low is going to send 0 to pin 3. Same also applies with relay 3, which is pin 4. Sending a signal of high is going to send 12 volts to pin 4 on the Arduino board. Sending low is going to send 0 volts to relay 3, which is pin 4 on the Arduino. You can change these here, but I have these just 2, 3, and 4 just to keep it simple. Okay, so in the setup, here's where we set how the pins function on the Arduino. Here I have them set for output because I'm going to either be sending a high or a low output, which is positive 12 volts or 0 volts. And remember, this setup code is only running once. So I'm telling it, as it starts up, initially send low voltage or no voltage to relay 1, relay 2, and relay 3. As we've noted up here, this represents pin 2, pin 3, and pin 4 on the Arduino respectively. Here, you can see what each one of these pins is going to do. So relay 1 goes to the boost controller. Relay 2 goes to launch control. And relay 3 goes to the blow-off valve control. So, because these are all starting up with low voltage, or no voltage to pins 2, 3, and 4, when the car initially starts up and the Arduino is powered up with positive 12 volts, boost control is going to initially be off, launch control is going to initially be off, and the blow-off valve control is going to initially be off. Hopefully you've followed this so far. I'm trying to keep this as simple as possible. Please give me some feedback down below and let me know how I'm doing. Okay. The other thing that this car or this project runs is an LCD display. Now the LCD display will show which current mode that I'm in. Let me show you that. Let me go back up top here. And here are our modes. Again, Valet, Power, Sport, Corsa, and Killer. Okay? So, mode 0, again, is Valet. Mode 1 is Power. 2 is Sport. 3 is Corsa. 4 is Killer. Just like that. Scroll back down. So as the car starts up, it's going to initially put on that LCD screen MR2 IL, which is my custom plate. Then it's going to wait 3 seconds, or 3,000 milliseconds. It also has an LED light that it's going to send, as this is RGB, so here's green, here's red, here's blue. It's going to send maximum, 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 which all this equates to white on the LCD, or rather on the LED. So as the car starts up, that stream's going to say Mr. 2IL or MR2 IL. The LED is going to all be white, and the boost controller, the launch controller, and the blow-off valve are all going to be off. Then it's basically going to write some simple code here. Here's the simple code. It's looking for it's looking for input from the joystick. Just on the y-axis, which is up and down. If you remember, what was that? Geometry? I think it was algebra. So x-axis is left to right, y-axis is up and down. I'm strictly using the y-axis for the joystick. So, it starts in mode 0. So then I say a simple if-then statement here. Let's take a look. So, it's doing evaluation. If the mode is 0, change the light of the LED. Change it to green. But if the mode is 1, change the light to red. Change the light to blue. As you can see here, it's setting 0 to green, 0 to red, but blue is at maximum. But if the mode is number 2, which number 2, here's 0, here's 1, here's 2, is sport, then you're going to do purple. We achieve purple by doing maximum red, maximum blue. But if the mode is 3 or 4, we're going to change the color to red on the LCD, or rather on the LED. Simple. But that just changed the color. That hasn't actually done anything. So here's how we actually do something. Here, it evaluates code. This is a function, next mode, and here's a function, previous mode. So, if the joystick is pressed all the way up, it goes to next mode. If the joystick is pressed all the way down, it goes to previous mode. So let's take a look at next mode. And just briefly, so you understand how this flows, the way that a function will work is when the function is called, the code will basically jump down here to the function, execute the function, and when it gets to the end of the function, it will come back to the point where it executed from. So after it finishes running the next mode function, it's going to come right back to here and continue to evaluate. So let's look at next mode. Here we are. This is the function for next mode. It's pretty simple. It takes a look to find out which mode is currently selected. And then it says, if you're already at mode 4, remember we have modes 0, 1, 2, 3, and 4. So if we're at 4 and we want to go up higher, what do we need to do? We need to go back to mode 0. That's what this code right here does. So it says simply, if the mode is less than 4, we're going to increment the mode. So meaning if the mode is 2 and we come to next mode, the mode will then be 3. But if the mode is 4 and we come to next mode, then the next mode will be 0. Hopefully you follow that. Again, if the mode is less than 4, we will increment the mode by 1. But if the mode is already 4 and we are triggering next mode, we will set the mode to 0. That'll allow it to go 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, instead of going 0, 1, 2, 3, 4, 5, 6, 7, because we only have 5 modes going from 0, 1, 2, 3, and 4. Hopefully you follow that. If not, let me know if I made this too complicated. Okay. So, once that's done, we can ignore this, and it will go ahead and say on the LCD screen, we have triggered next. It'll show that for a split second, and then it'll show the current mode. The current mode will depend based on our mode number. That will translate into actual text of saying valet or killer or Corsa. That'll show right there on the LCD screen. That's achieved right here through this variable. Then it will go to, jumping around here. It will go to check mode. What does check mode do? At this point, we have changed the LCD screen. We have changed the light for the mode, but we haven't actually turned any systems on or off. Here, check mode is going to achieve the functionality of turning systems on and off. Remember that pin 2, 3, and 4? Here we are again with relay 1, which is pin 2, relay 2, which is pin 3, and relay 3, which is pin 4. And you can see here on the side, I have listed what these relays do, or what these pins do. So, here in mode 0, as we said earlier, it's boost control off, launch control off, blow off valve off. This is a really nerf mode that the car starts up in. That way, it's great for rainy days. It's great when you just need to stealthy get around. You don't want to attract a lot of attention. This is a great mode to have. The next mode is boost control on, launch control off, blow off valve off. That's achieved by telling relay 1 to go high. So again, that's going to send positive 12 volts to pin 2. Pin 2 is connected to a relay. So 12 volts triggers that relay, and it closes the circuit by sending out the voltage to turn on the boost controller. Here in mode 2, we have relay 1 high, which is boost control on, relay 2 low, which is launch control off, and relay 3 high, which is blow off valve on. So this is going to turn on the boost control and the blow off valve. Mode 3, we have boost control on, launch control on, blow off valve off. And then finally, mode 4, we have everything on. So we have boost control on, launch control on, and blow off valve on. There we go. And then it does a simple check and changes the lights. Pretty simple. So this is all going to execute based on the mode that you're in. And once that's done executing, it's going to come back to the point where it was called, which was here. So now it's going to skip through this, it's going to go through this, and then it's going to loop. And it's just looking for input and just continuing to loop. Has this changed? How's this changed? And it will loop infinitely. So, how does previous mode work? Previous mode is just the inverse of next mode. So, remember with next mode, we're adding on to the mode by just incrementing it if it hasn't all the way up to 4. And if it is at 4, we're going back to 0. Well, previous mode works exactly the opposite. We're subtracting here. So we're saying, if mode is already at 0, we don't want to go to -1, so we'll go up to 4. So let's take a look here. So, if the mode is greater than 0, great. Then we're just going to subtract 1 from the mode. Otherwise, if mode is already at 0, the mode is now going to be at 4. It'll go through, it'll write to the LCD screen to let us know which mode we're in, just as before, and then it'll execute check mode again. And when check mode is executed, it'll go ahead and turn on or off the appropriate relays. That will result in giving our car the desired effect of having mode selection for boost control, launch control, as well as digitally controlling a mechanical blow-off valve. Hopefully, this has helped. Hopefully you can follow this. Please let me know in the comment section below. I can provide this code as well if you'd like to see it and mess around with it in Arduino. But this is just something that I developed and wrote for my MR2. It's my 93 MR2 Turbo that's on MegaSquirt. So thank you for watching. I hope you enjoyed it. I'm not planning on doing a ton of these in the future. I just want to do something simple. And I know you guys have been asking about how I'm writing code in Arduino. I just hope in the community that more people will get into writing Arduino and develop things for their car and give back to the community, because we all need some fresh ideas, right? And that's what I'm doing this for. So, as always, this is Justin. Thank you for rocking with us here at GoPro Earthing, and I'll catch you guys in the next video. But until then, GoPro Earthing. Peace.